In this lecture, we're going to learn about a very important concept in the IT world, which is virtualization and virtual machines. We're going to see what virtual machines are and why are they so useful, and learn all the main concepts of virtualization. Once we learn the concept of how virtual machines work, we're going to see it in action in the demo part by creating a Linux virtual machine on our computer using a popular open source software called VirtualBox. I'm Nana, and I have taught hundreds of thousands of people around the world how to advance their DevOps skills through my YouTube videos, online courses, and the 6-month DevOps Bootcamp. If you're new here, be sure to subscribe as I upload new videos all the time. Now let's see what a virtual machine is. Imagine you have a Windows computer, and as we learned, a computer has hardware like CPU, RAM, and storage. So we would have a Windows operating system on top of that controls how applications use these hardware resources. And on top of the Windows operating system, you would have applications that talk to Windows. So everything's cool here. Now, what if you wanted to use Linux instead? Maybe for your work, or maybe you just want to learn a new operating system. For that, you would need a machine with hardware resources and Linux operating system on top of that. And then you could run applications on that Linux operating system. So basically, you would need another computer, another laptop, where you would install that Linux operating system. Now, what virtualization is that you don't need a separate physical hardware or physical computer to install an operating system. You can install Linux operating system on top of the Windows OS or vice versa. You can install Windows on Linux or Windows and Linux on Mac OS. You can do any combination basically. You can even do Windows on Windows or Linux on Linux. And you can achieve that using something called a hypervisor. Hypervisor is a technology that allows hosting multiple virtual computers on a physical computer on top of the operating system that you already have installed. And one of the most popular hypervisors out there is VirtualBox from Oracle. And one of the main reasons for its popularity is because it's open source, and VirtualBox actually works on all operating systems. And it's pretty easy to use. So VirtualBox will let you create a virtual computer on your Windows computer by telling the Windows operating system, hey, can I have some of your hardware resources that you manage to create a virtual CPU, virtual RAM, virtual storage for my virtual computer? And as I said, you can have multiple virtual machines that are running on your computer through a hypervisor. Now, note here that you can only give the virtual computer the hardware resources you actually have available on that computer. If you have 8 gigabytes of RAM and your Windows is using 4 gigabytes and you give your virtual machine another 4 gigabytes, then you have no RAM left to be used for another virtual machine, so you can't create another one. So basically now you are sharing the hardware resources of one machine to run multiple virtual machines. So this means that as long as you have one computer with one operating system, using the hypervisor like VirtualBox, you can install other operating systems on top of it. But these virtual machines actually don't see each other and they're completely isolated. So the virtual machine itself thinks that it is an independent computer. It's the only one running on that computer. It doesn't even know that it's a virtual machine. And it doesn't know that it's hosted on top of another operating system. And that separation is actually great because if something happens to that virtual machine, something breaks inside or someone hacks inside that virtual machine, it won't affect the main operating system. The main OS probably won't even know that the VM has some issues, and it doesn't care. So when this happens, you can just delete that VM and create a fresh new one super easily. Now, you're probably asking, what is it actually good for? What is the usage or benefits of having a hypervisor and having virtual machines on your computer? First of all, it's really great for learning new operating systems. So now you don't have to go and buy a new computer and install Linux on it. You can basically just host it on your Windows machine if you want to. Maybe you want to just experiment and play around with an operating system, but you don't want to actually destroy or endanger your main operating system. So you can quickly spin up a virtual machine, you can play around with it and do all the stuff that you want. And then once you're done with it, you can just basically remove it. Another great use case for virtual machines is if you want to test an application, like a web application that you're developing. Maybe you want to see how that works and how it looks like in different operating systems in different browsers. So you may be developing on a Mac OS laptop and you want to see how your application performs on Linux machine in a Firefox browser. And you may also want to see how your application runs on Windows in an Internet Explorer browser. So you can create virtual machines for both of these combinations and test your application there. And when you're done, you can just delete them. Before moving on, I want to give a shout out to Kasten, who made this video possible. Kasten's K10 is the data management platform for Kubernetes. K10 basically takes off most of the load of doing backup and restore in Kubernetes from the cluster administrators. It has a very simple UI, so it's super easy to work with and has an intelligent logic which does all the heavy lifting for you. For my viewers, Kasten provided an ebook, Kubernetes Backup and Recovery for Dummies, which you can download for free. So be sure to check out the link in the video description. And now let's see what's the difference between type 1 and type 2 hypervisors. And this type of hypervisor that I just described, which is basically creating virtual machines on top of an existing operating system, is called a type 2 hypervisor. So you have the host operating system or the main operating system, which is already installed on the hardware on your machine. On that operating system, you install a hypervisor like VirtualBox, right? So on Windows, you install your VirtualBox, and then using the VirtualBox, you can now install guest operating systems. And the guest operating systems, as I said, will borrow the hardware resources from the host operating system. And the type 2 hypervisors are typically used for personal computers for the use cases that I just described. However, for big servers that companies are using, you have the second type of hypervisor, which is type 1 hypervisor, which actually works in exactly the same way. However, the main difference here is that instead of installing a hypervisor on a host operating system, you basically install it directly on the hardware. And that's why the type 1 hypervisors are also called bare metal hypervisors. So the hypervisor actually controls the hardware resources instead of talking to the host operating system whether it can borrow the resources for its virtual machines. So it sits directly on top of that hardware and controls everything. And some of the popular examples of type 1 hypervisors are VMware ESXi or Microsoft's Hyper-V. And once installed, basically the concept is the same as with type 2 hypervisors. You basically just install any operating system on top of it. So for big servers, you'll have one physical server with a bare metal hypervisor installed on it, and then you would have multiple virtual machines that are running on that hypervisor, all sharing the same hardware resources. And type 1 hypervisor is mostly what those big companies and big cloud platforms actually use to create and run their whole infrastructure. So when you create a server instance on a cloud platform like AWS or DigitalOcean or Google Cloud or whatever platform, you're creating these virtual machines on a physical server. And other users who create an instance may get a virtual machine on the same exact physical server as your virtual machine. But as I said, these VMs are completely isolated. They don't know anything about each other. So if something happens in one virtual machine, if someone gets hacked whose VM is on the same physical server, you won't even know it because each VM is running in its own isolated environment, right? They don't share a network, they don't share any resources, they don't share anything. They're completely independent from each other. Now, I give you some examples of why type 2 or also called hosted hypervisors are useful, right? For using them on personal computer. But what are the use cases of the type 1 hypervisors? So what is basically the big advantage of companies going out there and using this virtualization on their server infrastructure? One big advantage of using virtualization and hosting multiple virtual machines on one physical machine is efficient usage of hardware resources. Because now you may have these performant big servers on a cloud, but you can actually, or a cloud provider can actually let the users put together any combination of resources they want in their instance by picking and choosing how much CPU, how much RAM, how much storage they want. So they have this flexibility of choosing the size of their instances because everything is virtualized, right? The RAM and CPU and storage, so all of these resources are virtualized. So that's one big flexibility. So now the cloud providers, they can actually use up all their physical server resources by actually dividing them into small pieces that are then used by virtual machines. Now there is one more very important benefit and basically transformation that happened in IT industry because of virtualization. And that is basically abstracting away the operating system that is running on the hardware from the hardware itself. And that abstraction actually is a really big deal. And let's see why. So before virtualization, when a company had a server, like their own database server or a server where Jenkins was running, they would manage it themselves, like install an operating system directly on it and then start installing applications on that operating system, like installing and configuring Jenkins or installing database application, etc. And when the operating system is installed directly on a hardware without that hypervisor layer in between, that operating system is then tightly coupled to the hardware. That means if the hardware component of the computer failed, like the hard disk exploded or the motherboard failed, whatever, and you couldn't replace that component because maybe it was an old server and you couldn't find that component anymore, or maybe it was just not repairable anymore for whatever reasons, it meant your whole computer would be useless and the operating system and the applications you installed and configured on it and all the data would be gone.
AI is changing the game for app development. Firebase is here to help. We offer a platform.
So relying on that one physical box meant one point of failure and therefore high risk of losing all the services running on that machine. With virtualization, however, you have your operating system as a portable file that you can move around. And these files are virtual machine images. So that portable file, that image, will have the operating system, all the applications, the browser applications, the editors, Jenkins, whatever applications you would usually install on an operating system, all the configuration, files, pictures, documents, basically everything would be inside that portable file. And since it's a file, just like a picture or a text document, you can make copies of it and you can have backups of it, which is amazing and really useful, especially for companies. That means you could take your whole Jenkins server operating system and pack it into this portable image where all your Jenkins configuration, all your plugins, all your data basically would be inside, exactly as you configured it. and you can make backups of that image, which are called snapshots, right? So you'd have operating system image snapshots. So now if something happens to that virtual image where Jenkins is running, like you mess up Jenkins configuration or someone hacked into it or the hardware breaks, you can simply take that snapshot, that operating system image, and simply run it on a different computer with hypervisor on it. So by containing the operating system and the application layer of it in a portable file, you can secure your application and your work very easily. And you can move it around machines without being dependent on any physical server. So the virtual machines and the virtualization concept generally is very powerful, and that's why you see it everywhere in IT. It has completely changed the way we work. So whether you want to become a cloud engineer, a system administrator, software developer, or DevOps engineer, you need to understand the virtualization because you will be working with virtual machines. This video is actually a small part of a Linux module in the complete DevOps educational program. Linux is an important prerequisite for DevOps engineers. So in the Linux module, you learn everything you need to know about operating systems and Linux as a DevOps engineer. So if you want to become a DevOps engineer or build up your DevOps skills from zero to knowing all the required DevOps concepts and tools, be sure to check out our bootcamp and learn from a Docker captain, AWS container hero, and CNCF ambassador. With that, thank you for watching. I hope you learned a lot.
Join the free demo session for the Cybersecurity and Ethical Hacking Internship Program